Hi, I'm Patrick Nakagawa. Thank you for watching my presentation on my mobile learning project, Equation Time. The problem I chose to solve was improving student proficiency in Algebra 1, which is a class where I see a high area of need in high school, as it's the introductory math class that students often struggle with. To solve this problem, I would like to design an interactive practice system deployed as a mobile app where students can practice their skills and improve their proficiency. I use three theories as the foundation for my design. Constructivism is the idea that students learn best by doing, which led me to create a system of practice for them to improve. Adaptive learning is the idea that the content can adjust to the learner. An adaptive learning system can provide extra practice with areas of need and adjust the difficulty and complexity of the practice problems it generates. I do, we do, you do is an instructional model for presenting information to students by demonstrating a concept, guiding students through its application, and then having them practice it on their own. Before I began designing my app, I created a benchmark by searching the Apple App Store for equations and algebra. There were very few free apps in this category that offered fully interactive practice. Two of them were Hands-on Equations and Your Teacher Math. The features that they did not have that I wanted were a step-by-step equation solving process and the ability to generate new problems. That led me to develop some design elements and goals. The first was a step-by-step process where students could follow specific and easy instructions at each step of the equation solving process. The second was procedural generation, where the app would be able to generate an unlimited number of new problems for students to solve. Third was instant feedback, providing students with feedback as to whether they were right or wrong, as well as showing them the correct steps to the solution. Finally, I wanted the app to be capable of providing adaptation and differentiation by offering problems at different levels of difficulty and complexity. My goals for the design were for it to be easy, both to learn how to solve equations and to use the app, fast in that students could get into it right away and they only needed to use it for a short time, and finally that it would be good, that students would feel as if they had improved in solving equations and retain that knowledge for some time. With those elements and goals in mind, I started creating a prototype to demonstrate this interactive practice system. I chose to focus only on the critical topic of solving equations for this prototype and to avoid the App Store provisioning process and go beyond the pre-constructed interface elements of Adobe Air. So I decided to use Adobe Flash to publish a web app that could run on the browser, mobile device, or even a smartboard. I wanted to know if such an app would be easy to use and whether it could demonstrate my desired features. My final prototype is available at this URL and is linked in this post. The three elements of the prototype that you can see are notes that explain the step-by-step problem-solving process, guided examples that show each step of the process, and a practice mode that allows students to solve equations on their own. Based on feedback from my peers, I was able to change my research questions to reflect what I wanted to study about the usability of the prototype, rather than the potential long-term performance of a final product. I also revised the usability protocol accordingly to ask my questions as a natural dialogue, and for the scenarios to reflect the current state of my prototype. I also made some changes to the interface design, which you can see here. From the initial design on the left, I improved the buttons to be more attractive and easier to read, and moved the submenus to be on later screens to decrease clutter. Next, I performed my usability test with a high school teacher. A clip of our interaction follows.
I think it's invaluable that it shows the steps. Because the point of asking is you want them to identify what's the term we want to get rid of, right?
Yeah.
But then if you ask like what is the constant, you're just testing them on what is the constant versus like what term do I need to remove.
Right, or like you said, for them to look at the note and the note says move the constant term.
Right.
So yeah.
Right. Like I don't know how the thing works, like if like there's 3 fields for this one underneath.
Based on that feedback, I learned something I needed to improve on was the presentation of notes. By including the vocabulary terms as their own links, I could help students understand the key concepts, and by making the notes available throughout the practice and example modes, I could help to reinforce the problem-solving process the notes were intended to reinforce. Another topic of discussion was improving the examples and prompting the student during the guided practice. Some examples of that follow. The current prototype is on the left. A possible design on the right would improve on the example mode by explicitly stating each step, as well as moving the work so that the actions that have to be performed follow the name of each step rather than coming before it as they did originally. Another area where I received feedback was the possibility of adding prompts to the practice mode to help the students better understand. On the left, you have an example where the students would be prompted to click on a box to identify the constant term, whereas on the right, they could perform the work on their own and simply enter the answer. It was particularly challenging deciding where to draw the line between providing necessary guidance without going too far and doing the students' thinking for them. Overall, I felt like the prototype met most of its goals. The step-by-step process was designed into every aspect of it, yet I still need to improve on the way that information is presented to make it more available and useful. The procedural generation was successful in creating unlimited examples and practice problems. However, I only included a few different formats and structures in the prototype of the many that would be needed for a final version. The ability to provide instant feedback was well received. However, it caused problems for the ease of use when it prevented users from returning to a previously seen example. The app did not contain much differentiation, although it did demonstrate the range of possible complexity and difficulty by showing the easiest and hardest types of equations to contrast the two practice and example modes. It was easy for users to get in, but the interface still needs work, as users were observed clicking on things that weren't buttons, among other issues. Users agreed that it was generally fast to access and complete a set of problems in the practice mode. The quality of the interactive content was decently received, but the instructional design of the notes was an area for improvement. Overall, the prototype provided useful direction. I feel like the ideas I demonstrated in the prototype have potential, especially compared to the benchmark free apps. There is a cool factor for being able to take the necessary practice for Algebra 1 and put it into an app. At the same time, having to anticipate the needs of users places a much higher demand on the precision of the instruction, as the app's information needs to be totally unambiguous and suited to users who can't ask it questions. This led to a number of trade-offs and considerations, as even something simple like allowing students to put the variable on the left or right side instead of forcing one caused a lot of work behind the scenes and could potentially lead to more confusion than the restrictive hand-holding version. In the future, these and other improvements could be implemented, starting with the completion of the app by adding the remaining modes and adding new forms and structures of equations. After that, an extension could be done by creating companion apps to cover other topics in algebra. If this was the beginning with solving equations, further apps would include graphing, factoring, and solving quadratic equations. Finally, future versions of the app would need to be built in a way that could actually be deployed to devices in the native environment through the App Store. Also, account creation and login could be used to track, monitor, and adapt to the user's progress. Thank you for watching my presentation on my project, Equation Time.